you wonderful people? Hope all is well. This is going to be our last video. Um, Hopefully not ever. But our last video in the section we're doing on algebraic fractions. We're going to be solving equations, rational equations, like this one. Let's see here. Where is it? Is it washed out? There we go. We're going to be solving those using what we've learned about algebraic fractions. So I'm going to switch over to the document camera right now. As always, this is not a spectator sport. You need to be participating. If you want to learn how to do this, you've got to take notes, pause, ask questions. You can ask questions in the comment below. If you're a student of mine, you can send me an email. Um, you can leave me a question in Google Classroom. But you can also just leave a comment below. I'd be very happy to hear from you. Let's get to it, shall we? So look, we're going to solve this, and we actually have a little bit of a tool at our disposal that we couldn't use if we just had this. This can't be solved. The reason this can't be solved is this is not an equation. This is an equation. Forgive my sloppy handwriting right there. These are supposed to be this on the left of the equal sign is the same as this over here, right? Now, if you were being told to simplify this, you would have to get a common denominator, right? You'd have to be careful of that negative sign. This would be 3x minus 2x plus 2 over x minus 1 times x, right? And so when you were all done, you would get this. So this part right here equals that, right? Got a common denominator, did all that. You see our common denominator, though? Do you remember the common denominator is the LCM, right? So here's the trick we can do with this. It's not a trick. It's just, well, you know, if you multiply both sides of an equation, if you multiply one side of an equation by something and you do the same exact thing to the other side of the equation, it still stays, you know, of the same value. Well, what we can do is we can multiply both sides of this equation by the LCM of all of the denominators. So here's what we're going to do. We got to find the LCM of all denominators. Okay? So we already found the LCM of these two denominators. Since this is just 5, it's 5 over 1, right? So really, our LCM is going to be x times x minus 1, right? Now what we're going to do is we're going to multiply all terms, both sides, by our LCM. And what we're going to do is we're going to make sure we reduce, because it's the LCM of all of the denominators. When I multiply, all of these denominators are going to reduce and go away, and we're going to have just beautiful polynomial equation. No more fractions, right? No more rational stuff. Life will be good. Oh man, champagnes will fall from the heavens, shall we? We already know the LCM of all of these is x times x minus 1. Like that, right? So what we're going to do is we're going to multiply all of the terms, this one, and this one, because what you do to one side, you got to do the other. So we got to make sure we multiply everything on the left, everything on the right by this. And it's this over 1. We're not multiplying by, we're not getting a common denominator here. We are not getting a common denominator. What we're doing, we're not doing this. What we're doing is we're going to get rid of all the denominators. We're going to reduce, because look, when I multiply this term by this, watch what happens. We'll do the scratch work over here just for now, right? Here's what we got, right? This times this, we're going to do it right here. Yeah, you see? So what ends up happening is these two things reduce, and you're left with 3x over 1. So I'm just going to write 3x. I need to write over 1, right? When I do the same thing over here, do you see what's going to happen? The x's are going to reduce. Normally I wouldn't do the scratch work like I did right here, but let's go ahead and do that for this one right here right now, right? Let's go ahead and say x times x minus 1 over 1 times 2 over x, right? Those x's reduce, and you're left with 2x minus 2. Do you see? These x's reduce. 2 times x is 2x. 2 times negative 1 is negative 2. So this one, but look at this. look at this. It's not times 2. I almost missed it. You see that negative right there? It's times a negative 2. So that's what it's going to be. So watch. Let's make sure we're really careful right here, because that negative gets you all the time. You see one of those negative signs? You better slow down. So here's what we got. X and x are going to reduce. So what we're going to have is we're going to have negative 2 times x minus 1. Negative 2 times x is negative 2x, right? We did it right here. And then negative 2 times 1 is positive 2 over 1, right? But you don't need to write over 1. And now we have to multiply that one over here, right? So we're going to get x times x minus 1 times 5. So we're going to have 5 times x times x minus 1. We can simplify that a little bit. So here's what we're going to get. This makes x plus 2 equals 5x squared minus 5x. Now we're going to solve this, right? We've got to get everything on one side. Let's go ahead and do that. Let's go ahead and subtract. Let's put everything, let's move all of these things over there. So it's going to be 0 equals 5x squared. We're going to subtract x from both sides, minus 6x minus 2. Now, that's quadratic. Boy, if it was factorable, life would sure be good, right? But there's no difference of 5 and 2 that makes 6, so it doesn't work. So we would have to use, for this one, we'd have to use the quadratic equation. B squared minus 4ac over 2a. You see? And so a is 5. So here's what you get. You get 6 plus or minus the square root of 36 minus 4 times 5 times negative 2 over 2 times 5. Yeah? And so 6 plus or minus the square root of 5 times 4 is 20 times 2 is 40. A negative times a positive. Yeah, sorry, a negative times a negative is positive. So this is 40 plus 36, 76 over 10. So the plus would be this. The minus would be, hold on, the minus would be, you plug those both into your calculator, handy dandy calculator, see how it goes, and yeah, let's do it, shall we? So turn my calculator on. Let's see here. Let's see. Can we see the? Let's move it over here so we can see the whole calculator. Boy, little adjustment. There we go. All right. Still not good enough. There. Okay, so here's what we're gonna do. Here's what we're gonna do. Let's do this one right here. 6 plus the square root of 76. Now, if you hit divided by 10, all you're doing is dividing that square root of 76 by 10, or actually just the 76. So I'm going to hit equals. It gives me that number, and I'm going to divide that by 10. So I got 1.47. And then the next one, 6 minus the square root of 76. Divide that by 10, and you get rounded to 2 decimal places. All right, so those would be your 2 answers. Now, these kinds of questions are completely accessible to students that don't know the quadratic formula yet. A lot of times they turn out to just be linear. This one turned out to be quadratic, but a lot of times they do turn out to be linear and not too big of a deal. Let's try one more, right? Oh man, look at this ugliness right here. Boy, that looks just about impossible, right? Let's get our cameras all beautified here. Oh man, I gotta love technology, right? I just can't quite seem to get it to focus well. All right, there we go. It's about as good as we're going to get. All right, now, here's what you want to do. You want to find the lowest common multiple of all of those terms, right? But we also want to see if we can reduce anything first, because reducing makes everything smaller. You know, smaller is good, right? Smaller is good. So if I can make this smaller, life will be good. So here's what I'm going to do. I'm going to go ahead and see if I can reduce that. Look, I can take a 5 out of this. X minus 3. I can take, let's see, that's x minus 3 times x minus 2. Oh, life's getting good. Look at that. So here's what we got. X minus 2 over 5 plus 2 over x minus 4 equals 1 over x minus 4. I have a feeling this one's going to turn out to be quadratic too. Look at that. Anyway, we have to find the LCM of all of the denominators. So I have a 5 and I have 2x plus 4. So I think the LCM is going to be 5 times x minus 4. So here's what we're going to do. We're going to multiply all terms on both sides of the equal sign by that. We're going to reduce, see what happens. So when I multiply these two together, do you see how the 5's are going to reduce? And so what you're going to have is x minus 2 times x minus 4. Yeah? Over 1, right? And then when I multiply this times that term right there, the x minus 4 is reduced, and I'm going to be left with 5 times positive 2, which is 10. And then over here, when I multiply all the way over here, these two reduce, and I'm left with 5. So here's what you got. X squared minus 6x plus 8 plus 10 equals 5. Let's clean that up. Get everything on one side. X squared minus 6x. That's 18 minus 5, right? You're going to subtract 5. That makes 18. 18 minus 5, I'm pretty sure, is 13. It's quadratic once again. So, anyway, the point of this video is to get you to this point, to get rid of all of those denominators so that you can solve it. Hey, I'll leave some practice problems, a link to some practice problems in the description down below. If you have questions, please leave me a question, a comment, like, concern, and hope it's been helpful, and hope you have a great day.